Let's discuss a question from heat transfer. We have given with an aluminum sphere which is at a hot condition 250 degrees Celsius. Now it is quenched. It is kept in an environment where H is 20 watt per meter square degrees Celsius and the ambient temperature is 25. The sink temperature is 25 degrees Celsius. So obviously it will start cooling up, and we have to find out that from 250 how much time does it take to reach 80 degrees Celsius. Now this comes under a class of lumped heat transfer analysis, where we assume that the entire body temperature is same throughout. That is, it is 250 throughout. When it decreases to, let's say, 150, it will be 150 throughout. So there is no thermal gradient within the solid body. So that is lumped heat transfer analysis. In fact, you need to calculate the Biot number and check its value. The Biot number has to be very less for that. But anyhow, and the non-lumped cases are not there in your syllabus. So obviously you have to go with the lumped heat transfer analysis. So now the equation for the lumped heat transfer analysis is that, let's say at a time the ratio, let's say at a time t, when the temperature is 80, let's say the temperature, in general equation I'm writing, let's say the temperature is T minus T infinity by the initial temperature gap. This ratio dies down exponentially. So minus HA by rho CV into T. This is the equation. So let's substitute here. Everything is given. At a time t, the temperature, after time t, the temperature has to be 80 of the solid body minus the ambient temperature. Ambient temperature remains 25 throughout. That is the assumption. By the initial temperature is 250 minus 25. Okay, minus H. Now, okay, coming to first area. The area of this is surface area 4 pi r square, and volume of the sphere is 4 by 3rd pi r cube. So A by V, obviously, if you divide these two, it will be 3 by r. So directly I'll be writing in the place of A by B 3 by r. So H is given as 20, and A by V I'll be writing 3 by r. Okay, so 3 I have written. Rho is given as your 2707, and with the specific heat is 896. The diameter is 12 mm, so its radius is 6 mm. So everything I am substituting meters, so 0.006 into T. So this is the thing. So I can calculate this. Let's calculate what is there at the power of E. So if I calculate this, I get close to 0.004 T. So if I apply log on both sides, okay, then calculate T, I get T as close to 352.19 seconds, and divided by 60 I'll get it in minutes. So it's close to 5.86 minutes. So 5.86 minutes, answer is C. So remember, there's almost most of the time, once in 2 years or 3 years, there's always a question on lumped heat and heat transfer, and it's direct. There are only two categories of question, either the lumped heating or lumped cooling. Lumped cooling is nothing but just, in a sense, you can understand quenching. So this is in fact quenching. Okay, so 5.86 minutes. Thank you.